Well, thank you, everyone. My name is Nicholas Hannon from Woods End Laboratories. I'm the lab supervisor there. I've been there for 8 years, and as a company, we've been doing compost testing for 50 years now. Um, Doing it again. So, why compost test? Um, Producers, they need to know the nutrient content, the NPK, so that they can sell it. They need to know see the N ratio, carbon to nitrogen. They can go to the organic matter content, all important attributes to the compost when they're selling it. They also need to know, is it safe to use? Immature compost will harm plants and harm crops. Some are going for certification, such as the U.S. Compost Council seal of testing assurance. Some are looking at adding feedstocks or sure that their feedstocks that they're using are still good and it's not going to impact their test mixes. For lab, a lot of these tests can be easy to use, easy to do. And as we go through, you'll see a lot of them are very similar to soil or tissue testing. Sorry about that. I'm not sure why. So here I've got a list of the most commonly requested compost tests. These are all required for the seal of testing assurance through the Compost Council. And they all have their own set of methods. There's some differences that can be done in each one. But there is the test methods for the examination of compost and composting, also known as TMET, that has their own certified list of testing that everybody does for the seal of testing assurance. So when compost arrives, first thing you have to do is prep it. So you're going to take the compost and wet sieve it. You're going to run it through either one or several sieves, depending on the test package that they need. And this is to remove large stones, like pieces of wood, and other man-made inerts. You're going to take a beaker and weigh out typically 1 liter of compost. That allows you to get the bulk density of the compost. You're then going to run it through the screen. And then you're going to take what doesn't go through the screen and weigh that. That will get you your inert percentage. Very simple, very just labor intensive, it can be. The screen material is then dried with the compost, with the moisture content being measured gravimetrically. Same way as you would with soil. All tests are then performed on either the dried material or the screened material. Once it's dried, you do need to grind the material to make it more uniform to test it. You do not want to use a hammer mill. That typically won't shred it fine enough. We use this type of grinder here, which is a small sample gets ground through for further testing. You can always use something like a Wiley mill as well. There are several tests that you do identical to as you would with soil or with plant tissue. Moisture content we just discussed is gravimetrically. Total nitrogen or total organic carbon can either be done on a LICO instrument, or you can do total carbon on a LICO instrument and measure the inorganic carbon using a calcimeter. There's also another test, rarely done in soil, but you would do it the same way, which is testing for herbicides. You would typically use a red clover bioassay. In that method, you're going to plant 2 or 3 different plant species into either the compost or the soil. You're going to want to use at least 1 monocot, such as wheat, or 1 dicot, such as red clover. Allow them to grow for 2 weeks. After the 2 weeks, you're going to harvest them and compare them to a control mix that you set up at the same time for plant biomass, germination rate, and visual effects of herbicide. The red clover will not grow well. You'll see leaves curling inward, indicating that there's something negative in the compost or the soil that's impacting them. One unique thing to the compost, though, is you need to make sure the electrical conductivity is not above 2 decisiemens per meter. If it is, you will start to see herbicide effects. What looks like herbicide effects is actually just salt damage. So you're then going to want to mix it with your control mix to dilute it down. We always start compost at least a 50-50 mix. So anything 4 or lower, we just do a 50-50 mix, and that way we know there's gonna be no salt damage. If it's above a 4, we calculate it out to get it below a 2, so we don't see salt damage. Organic matter, most soil labs are doing a drying step for either 1 or 2 hours at 105 C, and then they increase the temperature. Most of us here probably are doing between 350 and 400 for 2 hours at second step. There are still some labs that go as high as 550 for that second step. There's also the walking black method. Most labs are moving away from that to the loss on ignition method. Compost, we typically only do the loss on ignition method, which is done at 550 for 4 to 8 hours. There is no typical drying step. You take the dry ground compost and run it. The organic matter content is usually much higher so that that little bit of residual moisture doesn't throw off your results. You're going to use the same crucibles and the same volume of mass as you would for soil. The only difference is just one step at 550. pH and electrical conductivity. Most of us in soil are going to do 1-to-1 with water or 1-to-2 and get both measurements. With compost, there are 2 different methods that are widely used. First, you have the saturated paste method, where we're going to take about 5 cc's of that compost and add just enough water until you just start to see some free water. As we down on the bottom of the tube, there's just a little bit of free water. That's the point we want to read the EC and the pH on that sample. The TMAC method, where you're going to be running it, if you're running it for certification, uses a 1:5 dry matter to water test. In that test, you take 10 grams of moist spring compost, 10 grams of dry equivalent, mix it with enough water to get 50 milliliters of water between what you add and what's already in the compost. So for example, if your compost is 50% moisture, you'll take 20 grams of this wet compost and mix in 40 milliliters of water. You then give that a mix and allow it to sit, and that will give you your 1-to-5 slurry. And you just read the pH and the EC on that. pHs can normally range in compost as high as 8.5, and EC is normally between 1 and 6 decisiemens per meter, although I've seen it as high as 25 or even 30. Ammonia nitrate. Nitrate's commonly done in soil, ammonia not nearly as much. Soil has a wider range of extracts or different ways of reading it, such as the colorimetric cadmium reduction. Compost, it's normally run with just water for both methods. You can either dilute it 1-to-40, 1 gram of compost, 40 milliliters of water, and then run it the same exact way you would with soil for both ammonia and nitrate. Or you can do the TMAC method, which you would use the same 1-5 slurry you just had for your pH and your EC. The ion selective probe is what we use. We find it's very quick and easy to use. They will connect either to a pH meter, to a VNC connector, or they have some that is Bluetooth to a tablet or computer. It makes it easy to get the whole graph and just get your data right there and you have it ready. Those probes can range anywhere from $200 to $500 per probe. Minerals and metal. Soil, we're all pretty much doing extractions, anything. Modified Morgan, Olson, maybe the 3 is the most common. Most commonly only looking for just the minerals and the nutrients for the soil. With compost, it's going to be a lot like the plant tissue. You need to do the full digestion, get the total minerals and metals. So there's many different ways. You got the microwave digestion, the digestion blocks, or as we use, we just boil the sample in some water. You take the sample into a tube, add the acid, and boil it for 30 minutes. And then you've got our digestion. So really just as simple as that. If you ash the sample, you can use a weaker acid. So we take the sample after it's been ashed, add enough to normal hydrochloric acid until there's no longer a fizzing reaction, boil that for 40 minutes, bring it to 40 milliliters, and then run that on our ICP. You're also going to need to make sure you're looking for the metals. It's very important because for certification, they need to be below regulatory limits. So we're typically looking at your cadmium, chromium, nickel, lead, arsenic, selenium, and mercury. All of these, except mercury, can be run on a regular ICP. Mercury will take special attachments to the ICP or special instruments that can do the cold vapor method. Due to the increased cost and the increased time it takes, a lot of labs do choose to subcontract that out rather than set up the mercury. And if you're not going for certification, mercury is not a requirement. Another thing to keep in mind is these concentrations will be much higher than soil and probably most plant tissues. I regularly see calcium, for example, to be anywhere from 1 to 10% in compost, or 10,000 to 100,000 ppm. So you need to make sure your standards go that high, accounting for your dilution. You also are going to be looking at all the other nutrients being as high as either 0.5% to 5%. I commonly see all those. Hopefully these metals aren't very high. Yes? You're running that now. Oh, yes, is what we're running it on. You can run it on about. Except mercury. Mercury is the one that takes special equipment to be able to run for it. So going back a little bit to the sorting of it, soil, this isn't something that we normally do, but some contractors, some landscapers need it for certain certifications, certain testing that they're doing before they lay it, as well as sometimes there's sand sorting that needs to be done for sizing of sand. With compost, this is a very important test. If somebody's just coming in, they want to know the quality of their compost. It's not certification. We will just do a quarter-inch screening. That gives us the inerts, one screen, quick, easy, and we can move on with the rest of the testing. Sometimes they want a complete panel of the sizing of the material. We'll go from 2 inches all the way down to 2 millimeter sizing, with taking the weight at each screen level to give us the inerts at each level and the percent that passes. The TMAC method goes from 2 inches down to 1/8 of an inch, getting the screening level at each point. Also, after you're done sorting through, you need to take all the inerts and look at it and analyze it. You need to visually see what is glass, plastic, metal, and wood. An important test for certification is what percentage is man-made and the percentage of the overall compost, as well as what percentage is considered sharp. They need to make sure that if that's being sold, people aren't going to stick their hand and get set. So we just nest the screens onto a bucket and manually put it through each screen. They do also sell apparatuses that you can just set it, it will shake it, and you just come back 10, 15 minutes later, pull the screens out and weigh everything through each screen. Respiration. In soil, there's several different ways and 2 different methods that it gets done with. You can do basal respiration, which is where you screen field moist soil and run it. And then there's the burst respiration, where we take the soil, dry it, grind it, re-wet it, and get the total burst respiration. 2 different methods. So the most commonly known one, I would say, probably the alkali trap. That's where you take the soil, or either method, put it into a jar, seal it with some sodium hydroxide, and then at whatever time point you elect, you remove it from the sodium hydroxide from the jar, and you titrate it to get how much CO2 was absorbed by the sodium hydroxide. This can be done either daily and reset up to get an average daily respiration, or you can do it just at 24 hours, or some people have done it 3 or 4 days later to let it sit and get the total after 3 or 4 days. There also are auger-based gels that can do this for 24 hours, such as the Solvita gel. The Solvita paddle gets put into the jar with the soil. We either set it up for basal or burst respiration. 24 hours later, you read the color change of the gel, and that will give you the respiration. There's also IR sensors, such as the Solvita Earth or different ergot flow-through sensors. These use IR cells inside the headspace of the jar, or it takes off a sample from the headspace and uses an IR sensor to read it, reads CO2 in the jar, and then we either manually do the math later, or it will calculate the math for you to get the CO2C from the soil. These tests of basal respiration usually takes about 90 grams of the field moist soil, First respiration will take about 30 grams of the dry screened soil. When we're talking respiration in compost, you're going to do the same exact methods of doing it. However, the one difference is everything's done as more of a basal respiration. You do it on the field moist or the moist compost. The alkali trap is the one required for STA certification. It does need to be set up and read every day for 4 days to get an app. To do that, you do need to make sure that the soil is at its ideal moisture, which is typically about 80% of the water holding capacity. The easiest way to do that is through a squeeze test. You take a fistful of the compost, and as you squeeze it, if you see water running out between your finger, it's too moist. You need to let it sit out and dry a little bit. If, when you open your hand, it crumbles, it's too dry. You slowly mix in some water, allow it to sit, and test it again. You're looking for it to stay into a ball, but not have any free water. Once you have that, for the alkali trap method, it requires a 1 to 3 day sit incubation at room temperature to make sure that there's no increase from moisture being added, no increase in the respiration. You then do your normal alkali trap with the titration daily. There's also the Solita paddle, which is a different agar-based gel that will be able to get you the respiration in 4 hours. And then the same IR sensors will do the same thing. With these tests, you're going to typically use about 20 grams of compost, although the Solita paddle one does take 90 grams of compost. So pathogens are another test that is required for certification. For your general STA certification, it does require either fecal coliform or salmonella. Some states do require both, but usually the client will let you know that. To certify a compost, fecal coliform must be below 1,000 most probable number per gram, or the salmonella must be below 2 most probable number per 4 grams. These tests do take quite a bit to get set up, but they're fairly easy. You can either do plate streaking, where you make a digestion, streak the plate, and look to see what grows, and you count the colony forming units. Based on the number of colony forming units you have, that will be able to calculate the most probable number. There's also a liquid broth dilution, right, where you dilute it down into several broths based on what grows. Then you can calculate the most probable number. These are basically the same test for either one, but based on the exact temperature requirements, the media requirements, and the timing requirements, it can be costly to get set up. We looked into doing this, and it was going to cost us about $3,000 just to get it stood up. So it is another test that can easily be subcontracted. If it is for STA certification, it would need to be done through another STA lab. So compost maturity. There's several different ways you can determine if a compost is mature. The TMEC method and the requirement for STA would be an herbicide bioassay using cucumbers. In this test, you take the moist compost and you mix it 1 to 2, 1 part compost to 2 parts saturated vermiculite. You then would set it up into a solo cup and plant 15 cucumber seeds into it. You then duplicate that, so you have duplicate reps, and you set up a control of just vermiculite also in duplicate. They then have you put a clear cup on top to act as a humidity dome to help make sure everything stays moist and the appropriate moisture. After the first true leaf on the controls open up, so you've got these first 2 leaves that open up side to side. There's a 3rd leaf that comes up the middle, and that's the true leaf. Once that one appears and is open on the control, that's when you harvest the plants. You're going to pull them out, roots intact, and you're going to measure the stem length and the root length, and you're going to count how many grew. And then you're going to compare that to the controls. And based on the comparative length, you'll get your percent vigor and your percent germination. Immature compost will lead to poor germination, stunted growth and stunted leaf growth, as well as short, black necrotic roots. Very visible, very easy to see that the compost is not ready for use. Another method that we routinely use is the Savita maturity test. And here you put a respiration agar-based paddle and an ammonia volatilization paddle into the compost and seal it. After 4 hours, you read the results of the two paddles based on the color change. You then can use the index to figure out where and how mature the compost is based on where it lies, based on the color of those two probes. This test is very quick, where this one will get you 4 hours, and the cucumber test will take anywhere from 10 to 15 days to get results. Also, the cucumber test will take 300 to 400 cc's of compost, and that compost is gone. This test will only take 90 cc's, and you can reuse the compost later for further testing. Lastly, you can just look at reduction in either respiration, organic matter, and the carbon to nitrogen ratio. As a compost matures, it is going to be using up the organic matter and the carbon source in the compost. So as that source depletes, the microbe activity will decrease. So you will see a reduction in the respiration from the compost and the organic matter and the C to N ratio. However, compost, when it dries out, as it does with soil, the respiration stops. So that's why it's important when we're measuring the respiration that we do it on the ideal moisture. Otherwise, you could get a false positive of mature compost, and then they add it to the soil, ticks right off again, and got ammonia volatilizing, killing all the plants. So in summary, what would be needed to just start doing compost testing? You would need some sort of grinder, something different than a hammer mill to shred and grind that material. You would need a way to read ammonium and nitrate. It can either be an instrument such as an HPLC or a seal or an ion selective probe. You would need standards that go to the appropriate ranges for what you're expecting in compost. Once again, calcium going as high as 10%, even if you're diluting it 1 to 40, that's still, you're looking at, 5,000, 10,000 ppm. They need to make sure your standards are going that high. You need sieves. You can start out with just a 1/4 inch, but if you're going to be doing any sort of certification or sizing, you're going to need a wide variety going from, once again, 2 inches all the way down to 2 millimeters. Then you need some sort of respiration setup, whether that be either Savita setup, an IR sensor or detector, or a urette and the chemicals needed to do the ultralight trap. And if you're not already doing most of the work on plant tissues, you would need a digestion setup, which can be just simple as a hot plate or a digestion block setup or a microwave digester. If you're going to do the full SCA testing packages, you need a mercury instrument to be able to measure that mercury yourself, and a pathogen setup, which would include an incubator, growth plates or the broth, and you would need an autoclave. Lastly, other considerations, if you're not already doing it, you need to have some sort of limbs or some way of reporting it. No point getting the samples in if you can't make a report, if you can't track it. So that would need to be on people's minds as you're setting it up. Any questions? So we have several different packages. For our control, we're working on setting that up now. There is a proficiency program through the U.S. Composting Council. So we are keeping some of those, the dried and ground materials, and I'm going to be setting that up to use as a control sample throughout the run, as well as the calibration run. The test packages for the complete SCA package, even though we have some contractors of it, that's only $400 a sample. And then if they're looking for some basic, is a compost good to use, that's about $200, and then $300 if they want the mineral content in the plant.
What's the process that you need to report back?
So oftentimes, it gets reported through the portal that regulates it. If we get a result back for reporting it that we know it's gonna fail, we let them know right away. Now, for the compost capsules, there's only two tests that can fail it, whether it's above the limit on the pathogen or if it's above the EPA limit on the heavy metal. So if we see that, we'll let them know right away, and then that gives them the option to retest. Yeah, proper control now. So that's for the herbicides, right?
Hey, I know on the, microbiology, you said AST only has the. People alcohol and sample, that's different, how many are serious as well, is that correct?
I'm not aware. We go through the SCA and the US Composting Council, and they require either one of those for their certification.
If you back up to the kind of earlier, you don't actually have to back up, but you mentioned the clover test for herbicide. Is that a documented method to use the use of clover and wheat specifically?
Yes. It is OECD, but I think it's 108. OECD 108. They give a list of the different plants you can use. We use the wheat and the red clover, and we also use French. But they do say in the method to use one monocot and one dicot.
So for a lab that was thinking about adding compost, the only add-ons are things that could maybe be subcontracted. Like mercury and maybe some of the fecal matter testing, things like that.
Yep.
Oh,
One of the big things, because if you're doing plant tissue already, a lot of this you're probably already doing. The one big thing also would be the sieves, so you need to be able to sieve it to remove the internet.
also talk about for your guys' turnaround time. So I mean, we're used to, maybe 24-hour, maybe 3 days. We're talking a lot bigger turnaround.
It depends on what they're looking for. If they're looking for the full package, it's obviously gonna take 2 weeks because the cucumbers are gonna take the 2 weeks to grow. If they're just looking for the nutrient content, or is this a general maturity, we'll use our Savita test, and we can get a result out within a week.
What is the, what are you talking about list price, right? For either option.
So the SCA package would be the $400. The industry standard is anywhere from $350 to $450. We do the 400. We do the compost for the full mineral package. It's $375. That gets you all the minerals, the nutrients, as well as maturity, and basically everything but the mercury and these package.
And what's the internal certification for the lab? So, or not internal, but to say I'm offering an SDA package, what certification? You have any certification?
Yes.
You have to have what they talk about that.
So the US Composting Council has what they call the PAC program. That's right where it's another proficiency program. They send out samples 3 times a year. You run all the tests you run on them, as well as subcontract the ones that are required for passing. They then do just the same proficiency test. You get your results. I'm assuming, I don't think they have strict guidelines right now. But yeah.
Okay, oh, you're here, yeah, that's just Bob, it's not AL.
It's not
AL,
it's not CTS, it's just all.
Yeah. Yes.
But it is required.
So Bob, it's hard to know when it's just Bob. It's gonna be market forces that are. affecting.
a lot of it, people want that certification. A lot of it, they want to be able to say, so the reason for the certification and the STA is so that people know when you go to a certified a certified compost producer, that their result could be done the same anywhere, to any one of the labs.
That's being driven because in the Northeast market, right, there's government level regulations.
Yeah.
Whereas I don't know that that exists.
But it is nationwide.
Office of the DOC. The DOC uses a lot of compost in their roadside projects, and they have certain requirements quality. And I think it's marketing too, it's a marketing opportunity for these, that there's seal from the US Office of Council, and the just that it's quality should be.
Present, they do fantastic compost.
Yeah.
Yeah.
Yes.
Can you highlight what you got?
So there are some differences. So the cucumber study is the one required for STA. They both are approved TMEC methods. This one, you're growing plants, it's gonna take 2 weeks. And the compost, once you're done, is this time. It's very good at being able to very quickly, and easily see, yes, compost is not ready, or no. It's good to go ahead and send it out. The Sovita test, that you can visually see it, but you need to get those results and then plot them on this little index chart here, and it will tell you from there where it is. So this one's going based off the respiration and the volatilized ammonia. This one is a little more involved to it based on how it interacts with the plant.
Is there data or work to say, hey, these are the same, get the same result out of it?
Yeah.
They both there, they both point towards compost maturity. But, it's not necessarily optimal.
It would be interesting to put together what we have to see how well they trend. Because currently when we do STA testing, we do both and report both out. So we get the percent vigor and the percent termination. And then we get our Sovita index.
Any flaws?